Hi, everybody. Back at the beginning of the semester, I'd spoke to you guys as a class about taking a few opportunities to try to run a class like a university lesson at times. And a couple of those things that I wanted to tackle was going to be you being given a set note and then trying to make sense of that written note in order to be able to understand your theory and then apply it properly. Well, over the course of this closure, we've had a number of days, but they've all been kind of attached to a video lesson. So to some extent, it's been like you've been sitting in lecture. I hope it's felt like that. Well, today I want to take one of those opportunities to go through and give you a written note. So I am assuming that you are watching this video then, per the instructions with the lesson, after you've gone through and read that note and you think you have what you need out of that note to be good with your theory. So what I want to tackle a little bit again is how do we get the most out of written material? So the number one thing, and I know we're going back a few months in this case, is about trying to be active with something. When we are active, we learn better with it. We have recall better with it. We feel more comfortable with the material. So, as you read through that note, I gave you a ton of theory on that page, but I'm hoping that a couple of things came true. First one, I'm hoping that because I put in some handwriting of some material on that first page, that you recognize, well, if your prof is going to include something like that in detail, then it must be important. So, the first thing I want to address is that top red box. When we talk about the amplitude, then we should be good that amplitude is half the height. So half of the distance between the max and the min. And we recall from grade 11 that the amplitude is the a value of your function. The next box down below, I often refer to as like your best friend. As you're working through, really you want to have that green relationship in your back pocket. That we know what the period of a function is. It's how long does it take to repeat a cycle. The cycle is one of the patterns, a complete pattern, a complete rotation in some cases. So as we work our way through then, if you can keep that green box in your back pocket, that the period of any function is 2 pi divided by k when we're talking about our sine and our cosine curves. Okay, hopefully then we were able to progress kind of to the next section of our lesson. And so now we come in on our examples. Okay, so then you have to ask yourself, why did the prof include these examples? What am I supposed to get out of them? So the first thing you want to do is I would have hoped that you could have gone through and considered all the properties of your function. So when the problem said, state the domain, range, and phase shift of the cycle, that you could have just looked at that equation and been able to go through some of that work. That I'm hoping that as we tackle the next 4 examples, on every single one of them, you tried it first. So I want you to look back at what you did with this note. Whether you were able to print off a copy, did you write some stuff down on it? Or whether you were just reading it digitally, okay, off to the side on a separate piece of paper, did you work through each problem? That what we want to get is we want to get to working through the problem itself way before we ever look at the solution. If you can do that during the lesson, then you have what you need. Reading is about as passive as you can get with the intake of information. You're just kind of letting it come at you. But the act of doing can make it come through. It can make it stick. You're now being active with the material. So I'm hoping that then when we take a look at problem 2, you've already gone through and you've answered problem 2 well before you took a look at what the solution was. Okay, second part then. I want to come to, why did the prof include these problems? that you're not going to get wasted time during lectures next year. Your prof will run their lesson, they're going to cover what they think you need, and then they're going to send you on your way. So, why did they choose to spend valuable lecture time talking about these particular problems? So, in order to do that, what we want to look at is what's different about those problems. So, let's take a look at one. I would hope that in a lot of cases, we're good that one maybe is just an intro problem. That in a lot of cases, to acquire new information, we often start from a starting point, or we have a starting point, that relates back to something that we know. So to start off with a pretty general trig curve, where you're talking about a vertical stretch by a factor of a half, and then a phase shift of pi by 2 left, that really isn't going to cause us much difficulty, hopefully. And so for us to be able to work through then, we should be okay to be able to tackle that one, and I would hope that the first one would have gone well. Vertical stretch and a horizontal shift. So if we're good with those, then let's take a look at problem 2. And one of the great questions to ask yourself is, why did they include this problem? Okay, why did they include that problem? So when you take a look at problem 2, what's different in problem 2 than in problem 1? We've got that 2. And so we know by the position of that 2 and by the operation, we're talking about a horizontal stretch. Now, if we recall, that stretch is by a factor of 1/2. And so that means where our sine curve used to take 2 pi to repeat, it's now going to repeat in half the distance, so it's only going to repeat every pi units. Notice our best friend is a relationship that we can use on that. We get a little confirmation, that is our k value, and so if we take 2 pi and we divide it by 2, then the period for that function is just pi. Okay, so problem 2 dealt with a horizontal stretch. Now, take a look at the examples of 3 and 4 and see what they lead us into. Okay, so now as we examine example 3, why do you think I spent your time wanting to include an example like 3? And I'm hoping that when we do that, we notice that we have our reflection in the x-axis. And so when we take a look at our graph, where our sine curve normally starts in the middle and rises, because of that reflection in the x-axis, it's now going to start in the middle and fall. Okay, you then take a look at the very last problem, problem 4. And why did I spend your time on 4? Well, you've got 2 options. As you take a look at what is included in 4 that was not included in the previous examples, and you do have 2 things. The first thing that I would maybe draw your attention to is, yes, we have that vertical shift. Now, when you take a look at the graph, you're wondering, okay, what's up with the graph? I just put the graph on sideways merely for space on the page. A vertical shift should not have been an issue for you. So why did I include number 4? It's because of that 1/2. Don't forget that your k value, or your horizontal stretch value, must be applied to everything on the inside of your function in order to be able to interpret your phase shift or your horizontal shift correctly. So there's one kind of key mistake here. If we recognize that we're going to have to factor out the 1/2 x so that we get a coefficient of 1 on our x, then if I take a half out of my half, I have a 1/4, and so it's a pi by 4, and maybe you can see my mistake. It happens so often, and I think it's just that we rush a little bit. But you take a look one more time if I was to re-expand that 1/2 in, I'm going to have a pi by 8 at the end of my equation when I should only have a pi by 2. So notice my act of factoring was incorrect. So let me get rid of all of that on the inside then, and let me make sure that I factor that correctly. I'm going to tell you that common mistake is so common that I would want everybody to pump the brakes right now and just say, okay, what would I multiply a half by to get me back to a positive pi by 2? And hopefully we're good then with just a pi. Now I get a little confirmation that as I expand that back, there's my pi by 2, and I am good. So be very careful as we kind of work our way through, but also when given written information, number one, you want to be as active as you can be with it. So you tackle all of the examples, then read through all the solutions. That's going to definitely help you to acquire what you need to, but also to make some common mistakes and to get an honest gauge of where you're at with the material. We often say it's pretty easy to read the solution to a problem, but could we have come up with that on our own? After we've got that, number two then, now we need to make sure that we take care of what was the important stuff. So we start to analyze what was covered in the examples. Why did they spend their time choosing those examples? And lastly, take a look for any little prof notes that are in there. Make sure that you have something emphasized that your professor felt necessary to do so as well. Okay, hopefully that lesson today worked well. It was a full review topic, and now your job is to kind of jump in and get a little bit of practice with transformations on your trig graph. Good luck.